This is my presentation for the technology project in blic 9, where we made circuits, and I made a light sensor circuit. Before I get into the schematics and notes and just different diagrams of what I've done and how it works, I'll start by just talking about what a sensor is. Now, a sensor is a device that is used to detect changes in the outside environment or quantities or events that appropriately produce an output, in this case a current, which turns on a light. However, there are different types of resistors. It doesn't have to be light sensitive like this one. It can be temperature sensitive, humidity sensitive, pressure sensitive, even ultrasonic or touch sensors are used for a bunch of different uses. Most prominently just fire alarms, which are then heat or smoke sensitive. Or even thermometers are kind of sensors. Now, let's take a look at the different kinds of components I used. Excuse me. Okay, first we have the transistors. Now, as you can see, this isn't an exact transistor. However, this is a schematic of how the transistor is built, or at least how it is formatted. With the emitter, we have here the base and the collector, all point in different directions. This is a tripolar transistor, to differentiate from bipolar transistor or something else. This is placed in the circuit in order to amplify or switch electric signals and electric power. And then we have the light sensor, which detects light and induces a current to, for say, turn on a lamp. And then we have the resistors. Now, resistors control the flow of electrical currents within a circuit, and they're made from materials like copper or carbon, which make it somewhat harder or slower for the current to flow through the circuit. And this can protect against voltage spikes and provide a proper voltage for your lamp in this case. I have used two kinds of transistors, 10K, as you can see here, and 1K, that is in kilo ohms, 10,000 ohms of resistance. Now, speaking of resistors, this is my main problem when making the circuit. See, first, this is the rough diagram. We have the light sensitive switch here. I haven't labeled this. One 10K resistor, transistor, the light, and the battery. Now, problem with this was whenever I plugged it in, the 6-volt battery would, how do I say this? It would short circuit and blow up the lamp, or at least destroy it beyond use. So after 3 tries and several different changed lights, I realized I'm missing a resistor, or I should add a resistor rather. So I added a 1K resistor here, attached the wire where it was on the 10K resistor, and well, voila, it works. The resistance controls the current in such a way that doesn't overflow and destroy the lamp. Sadly, this was about 3 lamps too late, so it took a bunch of time and took a bunch of broken lamps. Now, here is the prototype, the one which didn't work. Well, it worked for a little bit, a couple seconds. Enough time to take a picture, but then it's gone. I added a resistor here. It's a bit hard to see, but 1K resistor is right in between here, as you can see on this diagram, except they're flipped because I've drawn it wrong. So the 1K resistor is here, 10K is here. Alright, and now I will show a quick video of some YouTuber explaining different uses of the light sensitive switches, some that I haven't mentioned in here, that are more everyday life kind of things. Here we go.
Channel. Have you ever explored the auto brightness mode on your phone? Isn't it interesting how with changing light, the screen brightness automatically adjusts itself? How does this happen? Well, this has been made possible with the help of light sensors. Light sensors convert light energy into electrical energy. The application of light sensors range from their use in brightness control in your mobile phone to agriculture to their use in security alarm systems. In today's video, we'll be discussing a few common types of light sensors, which are photodiodes, photoresistors, phototransistors, and charge-coupled devices. First, we'll talk about the most common type of light sensor, the photodiode. Photodiodes have found their application from the remote controls of televisions to smoke detectors. Photodiodes consist of a PN junction which is connected in reverse bias, where the P junction is connected to the negative terminal of the battery and the N terminal is connected to the positive terminal.
This should give you a rough idea of how they are built and what they are made for. Now I'll show you a video of my circuit in work. As you can see here, I am covering and uncovering the light sensitive sensor, and it turns on, off and on, off and on. Alright, thank you for watching. Please comment and give feedback. Thank you.